this video, we're going to look at ways to visualize the relationship between two or more categorical variables using R. But before we do that, we're actually going to look at a small note set first that talks about standardized bar plots as well as more about conditional probabilities. So in the notes for this module, we already looked at both stacked and side-by-side bar plots. These plots are useful when we have frequencies on the y-axis. When working with sample data, it's preferable to work with relative frequencies or proportions because it's easier to infer what is happening in the population using proportions. Proportions can also help us compare different groups when the sample size for each group is not equal. And so consider this example from Module 8.1. Suppose a researcher is interested in comparing a person's diet to health outcomes. They decide to compare the Mediterranean diet to the American Heart Association's recommended diet. And the following data was published in the article Mediterranean Dietary Patterns in a Randomized Trial, published in 1998. And so we've seen this table before previously in the notes. And one thing that a researcher may be interested in is the different health outcomes conditional on diet. And in the notes, we talked about conditional proportions. So we're going to look here conditioning on the two different diet and then the proportion of the different health outcomes. And we can do that by summarizing in a table, computing those conditional proportions. So for example, if we look at the American Heart Association diet, we can see there were a total of 303 people who ate that diet. So conditional on that diet, we may want to know what percentage of people developed the different outcomes. So for example, 15 out of the 103 people developed cancer. And so if we take 15 divided by 103, we would find that's equal to 5%. And so down here what I have is a second table. And this table is going to have both the counts for each of the outcomes as well as the conditional proportions. So for example, if we look here in the cancer section, you'll see that we have the 15 people who developed cancer on the AHA diet and the 7 people who developed cancer on the Mediterranean diet. The percentages that are next to them, these are the percentage of people on each of the diets that developed cancer. So for example, again, if we take the 15 divided by the 303 people on the AHA diet, we would get 5% of people on that diet developed cancer. And then out of the Mediterranean diet, 7 out of the 302 developed cancer. And 7 divided by 302 is 2.3. So 2.3% of people on this diet developed cancer. And we could go through and do that for each of the outcomes. So a couple things to notice here. Since we are conditioning on diet, if we were to add up the percentages of the outcomes for each of the diets, this would add to 100%. And the same thing would be true for the Mediterranean diet. If we add up all of these percentages, they add up to 100%. Because again, to calculate these, we've conditioned on diet and looked at the percentage of the outcomes for each of the diets. What this allows us to do is we can look across diet, and if we see that the percentage of the outcomes for each of the diets is about the same, then that would tell us that there's no association between diet and outcome. In other words, each of the outcomes, whether you're on the AHA diet or the Mediterranean diet, your outcome would be the same, or the percentage of people for each of the outcomes are the same. But if we look here, we notice that for cancer, the AHA diet's a little bit higher. For fatal heart disease, it's a little bit higher. For non-fatal heart disease, it's higher. And for healthy, it's lower. So what this tells us is those on the AHA diet are actually, we're seeing those negative outcomes or those undesirable outcomes at a higher rate for the AHA diet than we are for the Mediterranean diet. And so this would suggest that there's an association between diet and outcome. Now, one thing to keep in mind is this is sample data, but this was a randomized trial. And so we need to learn a little bit more about inferential procedures and different what are called hypothesis tests that we can do to actually prove that this is likely happening in the population. But for right now, we can look at this sample data, and we do see that there's an association between diet and outcome. And again, we see this because conditioning on AHA diet if we look at each of those negative outcomes, we see they're happening at a higher percentage than they are for the Mediterranean diet. And then we also see the percent healthy is lower for the AHA diet versus the Mediterranean. So you'll often see tables that are like this, where you have some variable here that you condition on, and then you compare different outcomes. Now, another way that we could visualize this is by the use of a bar plot. Now, the bar plots that we saw previously, since they have those frequencies on the y-axis, they're not as helpful. Another bar plot that we could make is what's called a standardized bar plot, and I've seen these go by different names. But the idea is what happens here is for each of the conditions that you are conditioning on, so in this case we conditioned on diet, you have a bar for each of the diet. And then above the bar is stacked, and it looks at the different percentages, in this case for health outcome. Now, this particular software that I used used a comma instead of a period for a decimal point, but do know that this is 78.9, 8.3, 7.9, and 5. So this is a way for us to visualize what was happening previously in the table. So let's make that comparison. So again, looking here at the AHA bar, if we come up here to the AHA, right here at the AHA row, notice our percentages are 5, 7.9, 8.3, and 78.9. That is the exact percentages that we get here. And you could do something similar for the Mediterranean diet. The reason that these bar plots like this are useful is because they allow us very quickly to look, and we can see that for the Mediterranean diet, we have a much higher percentage of those that were healthy, and then each of the negative health outcomes are smaller than compared to the AHA. So it gives us just a different way to look at it compared to the table, and gives us this really nice quick visual reference. Now, this particular stack bar plot's nice because it includes those values in it. Sometimes you'll see the values inside of the bars, sometimes you won't. So what we're going to do is we're now going to see how we can do both of these things, both create the table as well as create the bar plots in R. Next, we're going to look at how to create this table and plot in R. And we're going to create the plot and table, not for the diet example that we saw in the notes, but for data from the BRFSS. All right, so here in RStudio, I have the Module 8 R code open. I also have the script that you're going to fill in for the assignment, but as usual, we'll talk about that one after I go through the full script for this example. So just like for the other examples we looked at, we're going to read in our data set. Here I'm going to read in the full Kentucky data set. Depending on your topic variable, you're going to want to read in the data that has been subsetted for your state. And then again, depending on your topic variable, it may be further subsetted to only include women or to only include men. And so again, that'll be dependent on your topic variable. So as always, I'm going to set my working directory, read in my data set. So if you need a refresher on how to set the working directory or to read in the data set, please see either the Module 6 video or the Module 7 video. So the first thing I'm going to do is to create a contingency table, and I'm going to work with the education variable and the pneumonia vaccine variable. So for the tables that you create, you're going to be comparing a demographic variable to one of your topic variables. So the very first thing I'm going to do is for each of my variables, I'm going to give it meaningful labels. We've actually seen how to do this previously in Module 5. So just kind of as a refresher, looking here at the education variable first, I'm going to call from my data set, the Kentucky data set, $, and then I'm going to create a new variable. It's going to be the education variable, and then I've placed _new next to it. And what I'm going to do here is I'm going to start with the Kentucky data. I'm going to call the original education variable, and then I'm going to change all of those numeric labels over to meaningful labels. And if you'll remember, these numbers and these labels, these do come from the code book. So if you're unfamiliar with this step or you don't remember this step, have a look back at the Module 5 video. All right, so I'm going to run this code. That will create that new education variable into the Kentucky data set. And I'm going to do the exact same thing for the pneumonia vaccine variable. Right. Next, what I'm going to do is to create a contingency table to compare both the education variable, my demographic variable, to my vaccine variable, which is a topic variable. So to create a contingency table, we're going to use the table function. So I'm going to create a table. So I first need to give this table a name. This table is going to compare education and pneumonia vaccine. So I've just given it some abbreviations here. EDU for education, underscore PNE for pneumonia. And so when you go to do this on your own, you'll give it some meaningful abbreviations. Then I'm going to call the table function. And what I've done here is I've called that new education variable from my data set, comma, the new pneumonia vaccine variable from my data set. And so when you do this, you'll list the demographic variable and then the topic variable. So once I run this, it creates the table. We can see the table appear up here. And then to actually see the table, I run the name of the table. And so here is our contingency table. So for example, in the survey, we can see there were 87 people who replied their highest level of education was less than high school and they had received a pneumonia vaccine, whereas of those people that said their highest level of education was less than high school, 38 of them had not received the pneumonia vaccine. For those that their highest level of education was some college or technical school, 171 of them said they had received the pneumonia vaccine, and 63 of them said they had not. And there were 34 that had unknown status. Now, one thing that we'll want for later on is we'll want to know how many total people answered this survey question. And we can do that by summing the table. That's going to add all these values together. And we see there were a total of 958 people that both answered the pneumonia vaccine question and the highest level of education question. And so at first, this might seem like a really low number, considering that 2,869 people total answered the survey for the state of Kentucky. But to look at why this number isn't as low as it might seem, we can go back to the code book to get some further information about these questions. So here we have the code book for the pneumonia vaccine variable, and notice that this question was only asked of those that were over the age of 65. So that's why we see that there's not many people here that answered this particular survey question, but we can see that's because they only asked people who were over the age of 65. Okay. So like we talked about earlier in this video, one thing that would be really useful is if we could create some conditional proportions. And so typically what we do is we condition on the demographic variable, and what that does is it allows us to look at different levels of the demographic variable to see if there are differences in the vaccine compliance. And so to do this, what we do is we use the prop table function, and we add in the name of that table that we created up here, and then the number 1. And so here is that conditional, those conditional proportions. And then to make this a little bit easier, what I'm going to do is actually convert this over to percentages rounded to 2 decimal places. And this line of code does that. So if we look at this table, similar to the table we saw earlier in the notes, what this does is it conditions on each level of the demographic variable. So in this case, education. So for those that their highest level of education was less than high school, we can see that 63% of them got the vaccine and 27.5% of them did not, and about 9.5% were unknown. So one thing to notice is these are going to add up to 100% across the rows since we've conditioned on education. Similar, for people who highest educational attainment is high school, we can see that 62.8% of them said yes, 26.62% of them said no, and about 10.5% were unknown. The reason that this is really useful for us is notice that as we look across the different levels of education, we see that about the same percentage have received the pneumonia vaccine and about the same percentage have not. Now, one thing that we can see though is we do see a slight increase once we get to college graduates or technical school graduates. Now, this is only a 3% increase, so whether or not this difference is due to chance, we would really need what's called a hypothesis test to tell that, and we're going to look at that later on in the course. The other thing that can be kind of tricky with these is notice if we look here at this unknown, we have 20%, and 60%. This is where the counts can actually come in and help us. Because notice if we come up here, those are actually only representing 5 people. So this is where typically if I'm reporting these values, I would put either include these counts in the table or put some kind of footnote along the bottom that lets your reader know that 20, and 60% really aren't that informative because they only came from 5 people. All right, so that's how we can create that relative frequency table where we condition on education. So the last thing we're going to do is look at how to create those stacked bar plots that we saw earlier with the 100%. So the code for this is kind of long, but that's in part because I've added in comments so you can see what you need to change for your variables. And so again, when we look at what we're going to do for this assignment, I'll show you how to make all of these changes. So, but for right now, I'm going to run the code. And you'll see we get this really nice stacked bar plot. And so across here, we have our different levels of highest education level. We also have the percents that are within education level. And then we have our different vaccination statuses. So notice if we compare this to our table that we have here, we can see that those at their highest level of education, less than high school, 9.4% of them didn't know whether or not they had received the vaccine. 27.5% of them said no, they had not, and 63% of them said yes, they had. And so again, what we're doing as we look across these different bars, we're trying to see, do the bars look fairly similar across different levels of education, or do they look different? If they look different, that suggests that there is an association between our demographic variable, in this case education, and whether or not someone receives a vaccine. And then keep in mind this unknown bar here, we kind of have a caveat here. It looks very different when someone has an unknown level of education, when we look at their vaccination status, but really there are only 5 people represented in this bar. So for this course, I'm having you leave them in there. There are different choices that can be made here. Some people will just remove those values and they would put kind of a note at the bottom of the plot and say these values have been removed. For you, what I would suggest doing is putting a footnote on your plot and just saying, the unknown bar isn't really reliable because it only represented 5 people in this case. And of course, you would change those numbers for your particular state. But again, comparing these 4 bars, we can see, there's not much difference. So this would suggest, there's not much of an association between highest level of education and those that receive the vaccine or not. We do see a little bit of a dip here when we get to college graduates, but it's not a huge difference. And again, later on, we'll be able to tell whether or not that difference is just due to chance because we took a sample, or is there actually maybe something going on with the population. So we're going to look at the assignment for this module. Okay. So here I have the assignment. So similar to the other ones, you're going to start out by creating an R script. I do have a template of one on Canvas for you. And what you're going to do is you're going to make 2 different comparisons. Each of those comparisons will be a demographic variable to a topic variable. And those demographic variables and topic variables, those were given in the module 5.3 assignment. So you can revisit that assignment to see the list of those different variables for the different topics. And so again, you're going to make both contingency tables where you condition on demographic variables, as well as bar plots where you do the same thing. and then you'll place those in a document. So let's look at how you'll do that in R. So located on Canvas, similar again to other modules, we have this template for your script. So the first part of the template is to read in the data. So similar to other modules, you'll come to the data section and copy that over. And then you'll create your first table and your first plot. So you'll want to just basically copy the rest of the code for this module and place that in here. And then you'll need to decide on what demographic variable and what topic variable you would like to look at. So starting out here at the top, you'll decide on your two variables. So you'll want to change your comment here to whichever of those variables you're going to be looking at. And then you'll want to go through and give meaningful labels for that demographic variable. And so again, to figure out what those labels are, you'll visit the code book, you'll match the numbers with what the labels are. These will have to be abbreviated versions of the labels so that you'll have enough room. And then you'll do the exact same thing for your topic variable. And so again, you should already have code that looks a lot like this from Module 5. We did this previously. So next, to create your contingency table, what you will change is you'll want to change the name of the table. So give just any abbreviation. These letters are up to you, but 2 3-letter abbreviations for the 2 different variables that you're comparing. Then here you'll give the name of your data set. And again, this will be the data set for your state, as well as subsetted for either males or females, or it may be your full state, depending on your topic. So if you're working with vaccines, it'll be the full data set for the state. If you're looking at cervical and breast cancer, it's going to be for females. And then if you're looking at colon cancer and prostate cancer screenings, those you'll probably want to substate just to men. You do have the choice for that one though. All right, so you'll give the name of the data set you're working with, the name of the demographic variable first, then you'll put comma, name of your data set, $, name of your new topic variable. And then you'll call the table. So whatever name you give the table here, you'll put that same name here, and then the same name inside of here. Now, this sum, the reason that that is important is that sum is what's going to give you the total number of observations that are used in your bar plot. So for example, when I ran this for the Kentucky data, notice this was equal to 958. And if we go over here and we look at the plot that I made, here in the title, I have 958. So that's where I'm getting the number of observations that are being used for the plot later on. And then to create that relative frequency table, conditional on the demographic variable, so you'll want to change this to be the demographic variable you're using. You will copy in the name of the table from up here and then make no other changes. And then same thing with the second line. You will copy in the name of the table, but make no other changes. So running these. So notice here we get our table. And then by running this line up here was where we got the counts. So at this point, you'll want to pause in your code and go to your write-up. So if we go back over to the assignment here, you'll notice that I have an example table here. And so this table matches with what we just saw in R. So let's look at how I've got this set up. So along the rows, I have the different levels for the demographic variable. So in this case, it's education. And you'll notice that I've got more room on this page, so I was able to give it, the labels, some more informative labels than I was in R. Along the top, I have my different vaccine statuses. So this will depend on your topic variable as to what you have here. And then I've included both the counts and the percentages. So for example, looking here at the table with the counts, you'll see that for less than high school and yeses, there were 87. So you'll see the 87 right here. And then the corresponding percentage is 63.4. So you'll see the 63.4 here. So the table that you put in the the worksheet will be a combination of both the table with the frequencies as well as the proportions conditional on the demographic variable. And so again, the reason that these tables are useful is because they allow us to compare across different levels of the demographic variable to see if we're seeing a change in the topic variable. And then the reason that the counts are so useful is, so we talked about this unknown highest education level where we saw that 20, 20, and 60%, and we saw that change in pattern. Well, if you include the counts, your reader can see, oh, it's just one person, and 3 people. And they can see, well, that row right there probably isn't very informative. We didn't have very many people there. All right, so the last thing you're going to do is, after you move that information over, is you'll then create a bar chart. And so like I said, it's a pretty big chunk of code here, but I've got comments to tell you exactly what you need to change. So for example, in this first line of code, you're going to change the name of the data set. You'll change the name of the topic variable, change the name of the demographic variable. In the second row, you'll add in the name of the demographic variable and then the topic variable. Change the demographic variable. So again, notice all you're doing here is changing the variable names and the data set names. Here, you'll change the demographic variable and then the topic variable. So I've got them in order for you. You're not going to make any changes here. On this line, you're going to make 3 different changes. You'll change the title to be something that's useful. And so here you're going to have your topic variable by demographic variable. And the value here, the total number of observations used to make the plot, that's what we used that line of code up earlier for, where we looked at the sum of the contingency table. For Y, you're going to have % within demographic variable. And so I've got a little note for you here. And then your X, that's going to be, the label for your demographic variable. And then to change the legend name, the last thing that you'll change is right here. You'll give that something meaningful. So for here, it was for vaccine, so that's vaccine status. If you've got a particular screening, you'll do screening status here. And then that's all you need to change, and you should be able to run it, and everything should run fine. If you have any questions, let me know. But again, you're really only changing labels, variable names, and the data set. Everything else stays exactly the same. And then to do your second table and plot, you'll just repeat that process. And again, just changing the data set names, the variable names, and the labels to be something meaningful. All right, so as always, if you have any questions at all, please let me know. Feel free to use the discussion board. It's really helpful if you post screenshots. If you're getting an error, that usually helps me see pretty quickly where the error is coming from. But I'm more than happy to help you troubleshoot this in any way. So just let me know if you have any questions.